Friends, welcome to my YouTube channel. In the last video, we were discussing about exploratory data analysis. This is the fourth video on exploratory data analysis. Sorry, not fourth. This is the fifth video on exploratory data analysis. In this video, I am going to compare between bivariant analysis and multivariant analysis. What are all the difference between bivariant analysis and multivariant analysis? Let's start. I believe this is the 13th video on feature engineering and the fifth video on exploratory analysis. So here the discussion is what the comparison between bivariant analysis and multivariant analysis. So I'm giving a quick introduction to feature engineering. What is feature engineering? In feature engineering, we convert data into features. That's what we do as part of feature engineering. You know this, and you need to understand. See, these are all the steps we follow as part of feature engineering. The philosophy of feature engineering is, as you know, the quality of your inputs decide the quality of your output. So the quality of the input is really important. See, a data scientist spend 80% of his time in feature engineering. So these steps, how do you handle these steps? It's really important as part of feature engineering. The steps are variable identification, univariate analysis, bivariant analysis, missing values treatment, outlier treatment, variable transformation, and variable creation. These are all the steps. Let me give a quick introduction to exploratory data analysis, EDA. EDA is a set of statistical approaches to explore and understand data. Here you need to do three steps. It's univariant analysis, bivariant analysis, multivariant analysis. You can watch the videos of univariant, bivariant, multivariant analysis under the playlist exploratory data analysis. See, here I am going to compare what's the difference between bivariant analysis and multivariant analysis. See, what is bivariant analysis? This type of data involves two different variables. That's what bi means two. Bivariant analysis finds out the relationship between two variables analysis, two variables. See, bivariant analysis, we give importance in analyzing the relationship between two variables. All regression problems there, what we do is the relationship between two variables. For example, if you want to understand, as pressure increases, volume decreases. So pressure, sorry, this is wrong. Pressure is inversely proportional to volume. You know this. So there is a relationship. They are inversely proportional. So volume is directly proportional to temperature. You learn it in physics. Volume. So there is a linear relationship between them. So this type of relationship only we are learning in bivariant analysis. Bivariant analysis finds out the relationship between two variables. As discussed, we can perform bivariant analysis for any combination of categorical and continuous variables. Variables are of two types. One is categorical variable and another one is continuous variables. For example, continuous variables, weights of the students in a class, continuous variable. Height of the students in a class, continuous variable. Then marks of the students in a class, continuous variable. Categorical variable means the gender of gender. So it can be male or female, only two categories. Categorical variable. The result of the exam, it can be pass or fail, only two categories. Categorical variable. So you got an idea about continuous and categorical variable. So bivariant means there can be three possibilities. There are three combinations, like the variables can be both, can be categorical and categorical. The first combination, second one categorical and continuous, third one continuous and continuous. So we have to use different methods for this. Example for bivariate analysis is the ice cream sales with temperature. As temperature increases, ice cream sales also increases. They are linearly related. They are directly proportional. For 21 degrees Celsius, it is 2200. 26 degree, again it is increased. Here temperature increase, sales also increase. So they are directly proportional. They are linearly related. So this is an example for bivariant analysis. Multivariant analysis means when the data involves three or more variables, it is categorized under multivariant analysis. analysis. This is known as multivariant analysis. If we have to analyze four variables at the same time, this causes an increase in dimensionality. It is extremely difficult for human mind to visualize the relationship between four variables or four dimensions. It's difficult for us to digest four dimension or five dimension. We can easily understand x, this is two dimension, x and y. When z axis means three dimension, it's also fine. But it's difficult for us to understand three dimension as well. See, our brain can easily understand two dimension. So this four dimension or five dimension, it is difficult to visualize it using graphs. It is so graph is not enough to visualize this multivariant analysis. So we generally use special statistical approaches and the softwares. We will see how it is. Example for multivariant analysis: a doctor has collected data on cholesterol, blood pressure, and weight. He also collected data on the eating habits of the patient. He wants to investigate the relationship between three measures of both measures of health. Three measures of health means cholesterol, blood pressure, and weight, and with the eating habit. So this is the data. BP, it is 120/80, cholesterol 165, weight 65, the calorie intake 1700 calories per day. So the another data. So how do we analyze? How do we predict by using these data? So for this we cannot use univariant. We cannot use bivariant. Here around four variables. Even food we have to again split into proteins, carbohydrates, and different types of food like meat, fish, or rice. See, all these things we have to consider. Then we need to go for multivariant analysis. So that's, see, bivariate analysis. Again, I have given an example for multivariant analysis. For bivariant analysis, I told you bivariant means there can be option of numerical and numerical, that is a correlation coefficient. At that time you will go for both the variables are numerical, we will go with correlation coefficient, Pearson correlation coefficient. There is a separate video on Pearson correlation coefficient in the playlist statistics. Please watch it. These terms: standard deviation, correlation coefficient, covariance, intra-quartile range. All these things, mean, median, mode, very important. Please try to learn it. Then, if it is categorical and categorical, we will go with chi-square approach. If it is numerical and categorical, we have to go for t-test, z-test, and ANOVA. So these are all the methods we use for numerical and categorical variables. This is the overall methods we use for bivariant analysis. For commonly used multivariant analysis techniques are cluster analysis. We can't go with other approaches like whatever methods we discussed for bivariant. So here we have to use for cluster analysis, factor analysis, multiple regression analysis, and another one is PCA, principal component analysis. These are all the methods we use, commonly used multivariant analysis. So that's about multivariant analysis. I'm just giving a comparison between, see, what methods we go for bivariant, what are all the methods we have to go for multivariant analysis, what exactly is bivariant analysis, what exactly is multivariant analysis. That's what I try to explain here. I think I think you understand this, what exactly is a bivariant analysis, multivariant analysis. An introduction towards that. The separate methods, again, we need to analyze, and I am going to prepare separate videos on this, is a test, t-test, all these separate videos. I am going to prepare. You can, within 2-3 days I will be uploading those videos as well. Thanks for watching. Please like, share, and subscribe. Thanks a lot.